Hi everyone, it's Christina and we're looking at question 7 of the Edexcel Paper 1 2018 A-Level Maths. So in this question, we're doing some integration. Let's start with part A. So we want to show that the following integral here is independent of k. So let's see how we could do that. So we have the limits 3k to k, which we need to evaluate this integral from. And we have 2 over 3x minus k dx. So let's do this integration first here. So that's going to give us ln of 3x minus k. Now, if we think about going backwards, because we want to make sure we have the right constant in front of our natural log expression here. If we differentiate ln of 3x minus k, we're going to get 1 over 3x minus k times by 3. Of course, we don't have 3 in our numerator, we have 2. So, in fact, we want to divide this whole thing by 3 and then multiply it by 2, so it's actually equivalent to what's on the left here. Then it's 2 over 3 ln 3x minus k. And then, of course, if we're doing just the integral of the fraction here, it will be plus c. Now, we have limits, so the plus c doesn't really matter in this case because we're evaluating this result between 3k and k. So if we do that, we can rewrite this a little bit. Let's bring the constant out. So 2 over 3 ln of 3x minus k between 3k and k. So let's write this out as 2 over 3. So ln of 3 times 3k minus k minus ln of 3 times k. That's just 3k minus k, like that. So that's 2 over 3. And then inside our first ln, we have 3 times 3k, that's 9k, minus k. So that's going to just be ln of 8k, minus ln of 3k minus k, that's just ln of 2k. Remembering our logarithmic laws, if we have ln of 8k minus ln of 2k, then we can write that as ln of 8k divided by ln of 8k. Let me be careful here. If I have ln of 8k minus ln of 2k, I can combine these by our log laws to get ln of 8k over 2k. Right, so now that's correct. And the 2/3 remains in front there. And so that simplifies to 2 over 3 ln of 8k over 2k. Well, that's just, the k's cancel. So we have 8 over 2, so it's just 4. So we can clearly see that the result from that integration is not dependent on k in any way. Otherwise, we would have k in our result somewhere, and we don't. So we have in fact shown that this integral is independent of k.